I'm Oyendrila and I am an expert in full stack. In this video, we are going to talk about recursive algorithms. In one of our previous videos, we talked about the different types of algorithms. Recursion was one of them. In recursion, the final solution of a problem is found by finding solutions to smaller subproblems. A larger problem with a large input size is divided into smaller subproblems. The recursive algorithm calls itself with smaller input values. It returns the result for the current input by carrying out basic operations on the returned value for the smaller input. Most of the computer programming languages support recursion by allowing a function to call itself from within its own code. A basic example of recursion is finding the factorial of a number. For example, 5 factorial is 5 multiplied by 4, 3, 2 and 1. So, the factorial function calls itself again and again with a smaller input size. Let us look at the steps in a recursive algorithm. First of all, we initialize the algorithm. A recursive algorithm needs a seed value to start. We need to check whether the current value is being processed and it matches the best case. If that happens, we process and return the value. We redefine the answer in terms of a smaller or a simpler subproblem or subproblems. In the next step, we run the algorithm on the subproblem. In the next step, we combine the results that we get from the subproblems and we formulate the final answer. After we get the final answer, we return the results. Recursion has advantages. Let us look at them. The job of recursive cases can be seen as breaking down complex inputs into simpler ones. In a properly designed recursive function, with each recursive call, the input problem must be simplified in such a way that eventually the base case must be reached. Recursion also has some disadvantages. Repetitively calling a function from within itself may cause the call stack to have a size equal to the sum of the input sizes of all the involved calls. It follows that for problems that can be solved easily by iteration, recursion is generally less efficient. And for larger problems, it is better to use optimization techniques like divide and conquer or dynamic programming. When we use a recursion, the space complexity increases. There are different types of recursion. One is direct and the second one is indirect. In direct recursion, the function calls itself. One example of direct recursion is tail recursion, meaning the recursive function calls itself for one last time to get the final output. The head recursion calls itself at the beginning of the program and arrives at the output. In indirect recursion, the function call happens between different functions. So, in this video, we have seen what is a recursive algorithm, its advantages and disadvantages. That's all for this video. I'll see you guys in the next video. Thank you.